It's 2:37 a.m. in a fleet yard outside Dallas, Texas. The air is still hot from the day, thick with diesel fumes and silence. Rows of work trucks sit parked under dim sodium lights. Chevy Silverados, GMC Sierras, worn-out utility rigs with ladder racks and dented bumpers. Everything looks tired, everything except what's about to start. A driver turns the key. There's a brief pause. Then the engine fires. Not loud, not violent, just steady, controlled, almost calm. That engine is the 4.8 Vortec, and most people have no idea it's one of the toughest V8s GM ever built. But what makes it so special isn't what it screams, it's what it survives, because this wasn't the engine GM advertised. It wasn't the one on posters or in muscle car legends. It was the one hidden in plain sight, the workhorse nobody bragged about until it refused to die. And once you understand what's inside it, you start to realize something strange. This underrated engine might actually be the one that held GM's entire truck empire together for over a decade. But how did an engine with no fame become the backbone of millions of trucks? And why did mechanics quietly start calling it the one you never replace, only retire the truck around it? The answer starts at the end of the 1990s. GM had a problem. The world was changing fast. Trucks were no longer just farm tools. They were becoming daily drivers, delivery vehicles, fleet machines, highway cruisers doing 300,000 miles without blinking. The demands were brutal. The expectations were rising, and the old small block engines, as legendary as they were starting to show their age. Fuel economy regulations were tightening. Emissions standards were getting stricter every year. Customers wanted more power, better reliability, and longer service intervals, all at the same time. The competition wasn't sleeping either. Ford was developing their Triton V8 family. Dodge had their Magnum engines. The truck wars were heating up, and GM needed something that could outlast, outwork, and outperform everything on the market. So GM rolled out a new generation of Vortec engines, the LS-based family. Clean slate, modern design, aluminum heads, better breathing, improved efficiency. At the top sat the big names, the 5.3, the 6.0. The engines that got attention, the ones in the commercials, the ones buyers asked for by name, the ones that won magazine comparisons and dominated spec sheets. But tucked underneath them was something quieter, the 4.8-liter Vortec V8, internal code, LR4, same architecture, same LS foundation, but slightly smaller bore, slightly different character, with a 3.78-inch bore and a 3.27-inch stroke. It was technically the smallest displacement of the family. On paper, that sounds like a downgrade, like the budget option, the engine you settle for when you can't afford the real one. But in engineering, sometimes smaller means stronger, because that shorter stroke changed everything. It meant lower piston speed at high RPM, less stress on the rods, less violent internal movement, and in a truck engine designed to run for hours, days, years without stopping. That matters more than peak horsepower. The physics are simple. Shorter stroke means the piston doesn't travel as far. Less distance per revolution means less acceleration force. Less force means less stress on every single component from the wrist pin to the main bearings. From the factory, the early versions produced around 255 horsepower and roughly 285 lb-ft of torque. Later versions climbed closer to 285 horsepower and 295 lb, depending on tuning and intake design. Nothing outrageous, nothing flashy, but here's the thing most people miss. That engine wasn't built for speed, it was built for punishment. Cast iron block, aluminum heads, sequential fuel injection, a bottom end designed with LS series rigidity, meaning a deep skirt block, and 6-bolt main caps holding the crank like it was locked inside a vault. The block itself weighed close to 200 pounds of pure cast iron, old school heavy, but that mass absorbed heat cycles like nothing else. It stabilized temperatures, it resisted warping, it gave the entire assembly a foundation that didn't flinch under load. The crankshaft was nodular iron, not forged steel like the performance engines, but it was cast strong, balanced tight, and supported by bearings that could handle continuous stress instead of peak bursts. The journals were thick, the throws were reinforced. Every dimension was calculated for longevity, not maximum output. The connecting rods were powdered metal. Same stuff used across the LS family. People dismissed them as cheap, but they were consistent, predictable, and they didn't snap under normal use, even when that normal use meant 14-hour days pulling loaded trailers. The pistons were cast aluminum with 3 rings, simple, basic, nothing exotic, but the ring tension was calibrated perfectly for oil control without excess friction. That meant less wear, better sealing, and longer life between rebuilds. You could run it low on maintenance. You could abuse it in fleet service. You could idle it all day with the AC blasting in Arizona heat, and it just kept going. The cooling system was overbuilt. The oil pump had enough volume to feed every bearing even when the oil was thin from heat. The timing chain was simple. No variable valve timing, no complex phasers to fail. Just a chain, 2 gears, and perfect reliability. But at first, nobody cared. Truck buyers walked right past the 4.8 and went for the 5.3. Same engine family, more torque, more marketing appeal. The 5.3 became the hero. The 4.8 became the leftover option. The one dealerships had to discount just to move off the lot. Salespeople didn't even want to talk about it. Why would you take the smaller engine, they'd ask. For just a little more money, you get the 5.3, and that's where the story could have ended. But then something unexpected happened. Fleet buyers started choosing it on purpose. Utility companies, municipal services, delivery fleets, contractors running dozens, sometimes hundreds of trucks at once. These weren't enthusiasts. They didn't care about 0-60 times. They cared about cost per mile, downtime, maintenance intervals, how often a truck came back broken, because they noticed something the brochures didn't say out loud. The 4.8 was harder to kill. One fleet supervisor in Oklahoma reportedly said, "We stopped speccing engines by power. We started speccing them by what comes back on a tow truck." And the 4.8 almost never did. Month after month, the numbers told the story. Fewer breakdowns, longer service intervals, engines that hit 150,000 miles and still didn't burn oil, trucks that started every morning, no matter how cold, no matter how neglected. A utility company in Colorado ran a test. They bought 50 trucks, 25 with the 4.8, 25 with the 5.3. Same workload, same routes, same drivers. After 3 years, the maintenance costs told a story nobody expected. The 4.8 trucks had lower overall costs, not because they were cheaper to fix, but because they needed fixing less often. But there was still skepticism, because how can the smallest V8 be the most reliable? And that's when mechanics started digging deeper. They pulled them apart after 200,000 miles, 300,000 miles, some even further. What they found didn't make sense at first. Bearings still intact, crosshatching still visible on cylinder walls, crankshafts worn, yes, but not destroyed. Oil passages still clean enough to read through, valve springs still holding tension, timing chains stretched maybe, but not snapped. One shop owner famously said, "It didn't look like it survived 300,000 miles, it looked like it just got broken in." Some engines were still running on original piston rings, original valve seals. Parts that should have been replaced twice over were still doing their job like nothing happened. And the pattern was consistent. It wasn't one lucky engine, it was almost all of them. One mechanic in Tennessee kept a journal. Every 4.8 that came through his shop, he documented the mileage and condition. After 5 years, he had data on over 100 engines. The average mileage before major work was needed. Over 275,000 miles. Compare that to industry standards, where most engines need significant work around 150,000 to 180,000 miles, and you start to see why people were paying attention. But even legends have limits, and the real test was about to begin. Because durability on paper is one thing, durability under full load is something else entirely. So GM put it into everything. Silverado 1500s hauling construction tools, express vans doing 12-hour delivery routes, Tahoe police interceptors idling for entire shifts. Sierra work trucks pulling trailers through mountain passes in Nevada heat. And the engine didn't just survive those conditions, it normalized them. Delivery drivers running stop-and-go traffic for 8 hours straight, police units idling outside crime scenes for 6-hour stretches, utility trucks sitting at idle with hydraulic systems running, PTO engaged, engine barely above 1,000 revolutions per minute for hours, the kind of abuse that kills most engines within a few years. But the 4.8 took it. Day after day, year after year, a FedEx driver in Ohio logged over 380,000 miles in his express van. Same engine, never opened, just oil changes, spark plugs, and one water pump. When they finally retired the van, the engine was still running strong enough to pass emissions testing. A police department in Florida ran their Tahoes hard, pursuit rated, full equipment load, idling with lights and computers running for hours every shift. They expected to replace engines every 100,000 miles. The 4.8S routinely went past 200,000 before retirement. And even then, they weren't failing. They were just being retired with the vehicle. But then came the engineering tension underneath all that reliability. Because the 4.8 had a secret weakness hidden in its own design philosophy. It shared almost everything with the 5.3. Same block family, same heads in many versions, same architecture, but that smaller bore meant less airflow potential. Less airflow means less power ceiling. The cylinders were narrower, the valves couldn't be as large, the combustion chambers had less volume to work with. And while that didn't matter at 2,500 revolutions per minute pulling a trailer, it mattered at 5,500 revolutions per minute when you wanted peak power. So while the 5.3 could comfortably push 320 horsepower in later generations, the 4.8 was capped lower. Even when tuned aggressively, it struggled to go far beyond 300,305 horsepower without major modifications. And at higher RPM, something subtle showed up. The engine felt like it was working harder than its bigger siblings to breathe, like it hit a ceiling right when the 5.3 kept climbing. Dyno charts showed it clearly. The 5.3's power curve kept climbing. The 4.8's curve flattened out, then dropped off sooner. But here's the twist. That limitation is exactly what saved it. Because less aggressive airflow demand meant less heat, less cylinder pressure stress, less detonation risk under bad fuel conditions. When a fleet truck in the middle of nowhere filled up with questionable gas, the 4.8 didn't care. It didn't ping, it didn't knock itself apart, it just ran a little slower and kept going. Lower compression chambers meant more tolerance for bad fuel. Less heat meant less thermal stress on head gaskets. Less peak cylinder pressure meant longer ring life and less bore wear. In real-world abuse, that meant survival. And GM engineers knew it. One former GM powertrain engineer was quoted saying, "We didn't design it to win dyno charts. We designed it to disappear into fleets." And it did exactly that. It became invisible. The engine nobody thought about. The one that just worked while everyone talked about the others. But the real moment of truth came in the mid-2000s, when mileage numbers started getting ridiculous. 200,000 miles wasn't impressive anymore. 300,000 became common. Some trucks pushed past 400,000 miles with original bottom ends untouched. A few reportedly crossed 500,000 miles, still running strong enough to pass emissions and pull a trailer. And still, the 4.8 kept showing up at auctions, still running, still starting, still idling like nothing happened. The odometers told stories most engines never lived to see. 6-digit numbers that rolled over and kept climbing. Service records that read like novels. Oil changes every 5,000 miles for a decade straight. One construction company in Texas had a Silverado they called the Mule. It was a 2001 with a 4.8. By 2015, it had over 470,000 miles, still on the original engine, still pulling a trailer full of tools to job sites every single day. They finally retired it, not because the engine failed, but because the frame cracked and the body was literally falling apart. The engine was still running perfectly, but there was a problem. Nobody celebrated it, because in the truck world, reliability doesn't sell dreams, power does. Commercials showed trucks pulling trains, climbing mountains, racing through deserts. Nobody wanted to see a truck idling in a parking lot for 400,000 miles. That's not exciting. That's just work. So the 4.8 lived in the shadow of its bigger siblings. The 5.3 got the fame. The 6.0 got the respect. The 4.8 just worked. Until one day, it quietly started becoming a secret. Enthusiasts discovered it. Swappers started pulling them from junkyards. Cheap LS-based V8s that could take boost surprisingly well. Turbo builds started appearing online, stock internals holding 400, even 500 horsepower with proper tuning. One builder said, "It's the cheapest LS you can destroy, and it still won't die." And that changed everything, because suddenly, the engine nobody wanted became the engine nobody could ignore. People started realizing you could buy a 4.8 from a junkyard for $300, bolt a turbo to it, tune it conservatively, and make more power than a built small block for a fraction of the cost. And when it eventually broke, which took longer than expected, you just grabbed another one, because they were everywhere. Drag racers started using them as test mules. Drifters swapped them into budget builds. Off-road guys threw them in rock crawlers because they were cheap and unkillable. The internet forums filled with build threads. Budget 4.8 turbo build. Junkyard 4.8 makes 450 GP. Stock 4.8 survives 20 PSI. The engine that was too boring for showrooms became the hero of grassroots motorsports. But the real climax of its story wasn't on a racetrack. It was in survival. Fleet after fleet realized something strange. The trucks were aging. Transmissions were replaced. Suspension components worn out. Bodies rusting away. Frames cracking from stress and salt. But the 4.8 engines, still running, still starting in winter mornings, still hauling, still idling through summer heat waves. In some cases, the engine outlived the vehicle itself. Trucks were being scrapped with perfectly good engines still bolted inside. Engines that could easily go another 100,000 miles if someone just put them in a different chassis. And that's when the reputation finally shifted. Not through advertising, not through racing glory, but through exhaustion. The kind of endurance you only notice when everything else around it fails first. Mechanics started pulling them out of retired trucks and setting them aside, saving them, because they knew those engines were worth more than the scrap value of the entire vehicle. Entire businesses started around pulling 4.8s from junkyard trucks and reselling them as replacement engines. Not rebuilt, just cleaned up and tested, because they didn't need rebuilding. By the 2010 S, newer engines started replacing it, more efficient designs, direct injection, AFM systems that shut down cylinders to save fuel, lighter materials, tighter emission standards, and slowly, the 4.8 Vortec faded out of production. The last ones rolled off the assembly line without fanfare, no special edition, no commemorative plaque, just another engine code discontinued in the march toward efficiency. But it never really disappeared, because used ones kept running, swapped into project trucks, pulled from wrecked fleets, bought by people who didn't care about horsepower numbers, just survival. And today, if you ask a seasoned mechanic what engine they trust in a beater truck that just has to run, you'll still hear it. The 4.8, not the fastest, not the strongest, not the most famous, but maybe the most unkillable. You'll find them in farm trucks still working the fields, in hunting rigs that sit unused for months then fire right up, in winter beaters that start at minus 20 degrees without complaint, in work trucks that have seen 3 different owners and outlasted them all. So what makes this engine so unforgettable? It's not one dramatic victory, it's not a racing dynasty, it's something quieter, a design that prioritized survival over spectacle, a V8 that accepted its own limits and turned them into strength. Because in the end, the 4.8 Vortec didn't win by being powerful, it won by refusing to quit. And that's why mechanics still talk about it like a secret they accidentally discovered in the middle of a junkyard, an engine that shouldn't have mattered, but somehow outlived everything built around it. If you really understand that, you start seeing it differently, not as the smallest Vortec, but as the one that proved endurance beats fame every single time. And maybe that's the real lesson hidden inside it. Sometimes the most underrated engine isn't the one nobody noticed, It's the one that kept running long after everyone stopped paying attention. The one that survived the hype, outlasted the competition, and quietly became the foundation of an empire nobody saw coming. The one that proved you don't need to be the biggest or the strongest to be the best. You just need to be there, every single day, no matter what. If you enjoyed this story, tell me what you want next. Another forgotten GM legend, a brutal rivalry, or an engine that failed so hard it changed an entire industry.